circular motion. Write down the definition of circular motion. If an object moves such that its distance from a fixed point is always same and its path lies in a two-dimensional plane then this type of motion is called circular motion. This fixed point is called center of the circle. And distance from the center is called its radius. Now, I said that path must be in a two-dimensional plane. Well, if we remove this restriction, then if an object moves on the surface of a sphere, तब भी उसके लिए बाकी की सारी चीजें वैलिड रहेंगी. If an object is moving on the surface of a sphere, then its distance from the center is same. But in circular motion, what is special that this circular motion is part of two-dimensional motion, whereas sphere is what? A three-dimensional thing. And therefore, we say that if an object is moving such that its distance from a fixed point, this fixed point is what? Center. Remains same throughout and it moves in a two-dimensional plane. Now, जब आप सर्कुलर मोशन की बात करते हो तो दो तरह के सर्कुलर मोशन होते हैं. पहला, if object is moving with v and every time it is moving with v only, that means speed of the object is always what? Same. You can see that direction is continuously changing. What is happening in this case? V or magnitude of velocity is what? Same. Remember, V is not same. V is not same. This is velocity vector, and vector has got two things, magnitude and what? Direction. चाहे कुछ कर लो, circular motion में direction तो change होगा ही होगा. Direction लगातार क्या होगी? Change. And therefore, in circular motion, velocity can never be same. In fact, you can write down this as a statement. Write down the statement. In circular motion, velocity can never be uniform, as its direction continuously changes. Direction of the moving object continuously changes. But आप क्या कर सकते हो कि भाई हमारा ऑब्जेक्ट 5 मीटर्स पर सेकंड से मूव कर रहा था. अब थ्रू आउट ये 5 मीटर्स पर सेकंड से ही मूव करता रहेगा, तो आप क्या बोलोगे? स्पीड, मैग्नीट्यूड ऑफ वेलोसिटी, इट इज व्हाट? सेम. ये जो सर्कुलर मोशन है इसको आप बोलते हो यूनिफॉर्म सर्कुलर मोशन। So what is the meaning of uniform circular motion? That speed is what same, डायरेक्शन आप कभी भी सेम नहीं रख सकते। Now look at this circular motion where speed is also changing. Let's say at this point speed is v1. When it reaches this position, speed changes and becomes v2. Somewhere here, speed changes and becomes what? v3. Speed is also changing. Magnitude of velocity is also changing. V or magnitude of velocity. This thing is also not same. This equal sign means what? V is same as magnitude of velocity. But this whole thing is not same. And direction आपको पता है कि लगातार क्या होगी? Change. अगर ऑब्जेक्ट इस तरह से मूव करेगा, that speed is 5, 6, 7, 8, 9, 10, 11, continuously changing, increasing or decreasing whatsoever, you say that this thing is non-uniform circular motion. In uniform circular motion, speed remains what? Same. Direction always changes. In non-uniform circular motion, even speed is not same. Direction तो change हो ही रही थी. Now, ये जो कैटेगरी है यूनिफॉर्म एंड नॉन यूनिफॉर्म, क्या सिचुएशन डेवलप होती है कि ऑब्जेक्ट यूनिफॉर्म सर्कुलर मोशन करता है? क्या कंडीशन ऐसी डेवलप हो जाती है कि ऑब्जेक्ट नॉन यूनिफॉर्म सर्कुलर मोशन करता है? विल डिस्कस दीज थिंग्स नाउ। अगर हमारे पास एक ऑब्जेक्ट है एंड इज मूविंग इन दिस डायरेक्शन विद वेलोसिटी v, हम देख रहे हैं कि क्या चीज है जो 1D क्रिएट करती है, क्या चीज है जो 2D क्रिएट करती है। Although we have seen this thing in kinematics, but let's revise that part again. If an object is moving like this and force is also present in this same direction along the line of the velocity, it can be like this or it can be like this. In this situation, V, when I do not use an arrow, it means magnitude. V is going to change. This V is something which is going to change. Speed, magnitude of velocity is going to change. Direction, it will remain what? Same. Same means along this line only. If force is in the opposite direction, then velocity as such will change its direction from this to this, but line of motion will be what? Same. Now consider this situation. If object is moving like this and force is in this direction, this angle is what? 90. If force is perpendicular to the velocity vector, तो आपको पता है कि किसी भी वेक्टर का अपने से 90 पर क्या इफेक्ट होता है, जीरो. This force cannot change magnitude of this velocity. If force is perpendicular to the velocity vector, then it cannot change magnitude of the velocity. थोड़ी देर में स्टेटमेंट हम नोट करेंगे, लेकिन अभी के लिए this situation means v or magnitude of v, this thing will remain what? Same. क्योंकि फोर्स का वेलोसिटी के डायरेक्शन में कोई कंट्रीब्यूशन नहीं है, this angle being 90. But this is a situation which you can easily visualize. Suppose you're moving in this direction and a force acts like this. If you're moving like this and a force acts like this, you can see that it will produce what? Change in the direction. If you're moving like this, and a force is acting like this, that will only change what? Magnitude. Situation number one. But if you're moving like this and a force is acting perpendicular to your velocity, then this direction part will change. Now write down these things in statement form. If force acts along the line of the velocity vector, then only magnitude of velocity inside the bracket speed will change. There will be no change in the direction, and therefore its path will be one dimensional. अगर आपने डायरेक्शन ही चेंज नहीं किया तो फिर पाथ क्या बन जाएगा? वन डायमेंशनल. Now write down the second statement. If force is perpendicular to the velocity vector, then as it doesn't have any effect in the direction of velocity of the object, magnitude of velocity will remain same. Magnitude of velocity will remain same. In this situation, this force changes direction of the velocity. In this situation, force changes direction of the velocity, thus producing a two-dimensional path. Now, Look at this third situation. If object is moving like this, force makes an angle of theta with the velocity vector, then this force has two components. This component, you know, is F cos theta, and this component is F sin theta. F cos and F sin. This thing is what? This thing says that F cos theta is in the direction of what? V. तो ये जो F cos theta है, ये क्या करने वाला है? ये first situation है. Force is in the direction of V. This F cos theta, since is in the direction of V, it will change magnitude of velocity. This F sin theta is perpendicular to what? Velocity vector. अगर ये F sin theta 90 पर है, then you can see that अगर force velocity से 90 पर है, तो वो केवल क्या change करता है? Direction. This F sin theta is going to change direction. This F cos theta is going to change magnitude of velocity. Will change magnitude of velocity. This F sin theta will change direction of velocity. अब अपने यूनिफॉर्म सर्कुलर मोशन एंड नॉन यूनिफॉर्म सर्कुलर मोशन इनके पास चलते हैं. In uniform circular motion, what is happening? V magnitude is what? Same. अगर magnitude same है और केवल क्या change हो रही है? Direction. So I hope you can see there can be no force in this direction. क्योंकि अगर velocity के direction में force होता तो उसका magnitude क्या कर देता? वो change. Which means in this first situation, force is in this direction. This is the direction of force. कहाँ लग रहा है? 90 पर. इसलिए केवल क्या इसने प्रोड्यूस किया है? डायरेक्शनल चेंज. और आपको इस फोर्स का नाम पता भी है. दिस फोर्स इज कॉल्ड सेंट्रीपिटल फोर्स. ये जो ऐप दिख रहा है, दिस इज कॉल्ड सेंट्रीपिटल फोर्स. बाद में इसको डेवलप करेंगे, लेकिन अभी के लिए आपके दिमाग में क्या कॉन्सेप्ट फिट हो गया? सेंट्रीपिटल फोर्स. व्हाट इट डज? इट ओनली प्रोड्यूसेस व्हाट? चेंज इन डायरेक्शन. क्यों? क्योंकि वो हमेशा वेलोसिटी से कहां लगता है? 90. अब आपको पता है कि वेलोसिटी इज अलोंग द टेंजेंट. टेंजेंट से 90 जो भी चीज होगी वो हमेशा कहां पॉइंट करेगी? टुवर्ड्स द सेंटर. And therefore this name centripetal force. So if we are discussing uniform circular motion, केवल कौन प्रेजेंट होता है? centripetal force. Now let's look at this situation. Hopefully यहां क्या होने वाला है आपको आइडिया लग चुका होगा. हमारी जो वेलोसिटी का मैग्नीट्यूड है, दैट इज ऑल्सो नॉट सेम. जो मैग्नीट्यूड है वो लगातार क्या हो रहा है? चेंज. बिकॉज ऑफ दिस, इस ऑब्जेक्ट पर एक फोर्स वेलोसिटी के डायरेक्शन में लग रहा है, इस फोर्स को हमने बोला एफ टी. What is Ft? Ft is tangential force. Small t for tangential. क्यों लगा है ये वेलोसिटी की डायरेक्शन में? क्योंकि वेलोसिटी का मैग्नीट्यूड क्या हो रहा है? चेंज. और अगर आप मैग्नीट्यूड चेंज करना चाहते हैं, then force must be present in the direction of what? Velocity vector. जो फोर्स कंपोनेंट वेलोसिटी के डायरेक्शन में है, दैट इज योर टेंजेंशियल फोर्स. लेकिन आपको पता है कि अगर सर्कुलर मोशन है तो डायरेक्शन तो चेंज होगा ही होगा. अगर सर्कुलर मोशन है तो डायरेक्शन चेंज होगा ही होगा. और डायरेक्शन चेंज करने के लिए फोर्स कहां लगना चाहिए? वेलोसिटी से 90. तो वेलोसिटी से 90 डिग्री पर ये जो फोर्स लग रहा है, वी नो दिस फोर्स इज कॉल्ड व्हाट? सेंट्रीपिटल फोर्स. ये चीज कहां पॉइंट कर रही है? टुवर्ड्स द सेंटर. And therefore, in non-uniform circular motion, we have two forces. One is what? Tangential. What it does? It changes magnitude of velocity. In the other force component is what? Fc. Fc is what? Centripetal force. What it does? It changes direction. किधर act करता है? Towards the center, perpendicular to the velocity. अगर आपको Ft and Fc ये दो चीज दिख रही हैं, तो आपको एक और कहानी यहां पता लग चुकी है कि there are two forces. One is Ft, the other one is Fc. You're looking at two force components, which means जो हमारा total force है. How do you generate total force? You will complete the rectangle and join this diagonal. Put this arrow. ये जो black arrow है, ये है आपका Ft. What is capital T? Total force. What is F total और Ft coming? अगर दो वेक्टर 90 पर होते हैं तो उनका रिजल्टेंट क्या हुआ करता है? रूट ओवर एफ सी स्क्वायर प्लस एफ टी स्क्वायर. In non-uniform circular motion, total force has two components, centripetal and tangential. Whereas in uniform circular motion, if I ask you what is F total, if I ask you what is F total or F T, तो आपको पता है कि इस सिचुएशन में there is no force in this direction. You can say that in this situation tangential force small t is what? 0. अगर टेंजेंशियल नहीं है तो फिर केवल कौन प्रेजेंट है? सेंट्रीपिटल. अगर केवल सेंट्रीपिटल प्रेजेंट है तो इस सिचुएशन में हमारा टोटल फोर्स is nothing but centripetal force. Now wrote down these things in the statement form. I hope इतनी कहानी समझ में आई होगी कि क्या है जो 1D 2D क्रिएट करता है and then in 2D किस तरह से आप यूनिफॉर्म सर्कुलर मोशन डेवलप करते हो और किस तरह से आप नॉन यूनिफॉर्म सर्कुलर मोशन डेवलप करते हो. Write down these things as in the statement form. In uniform circular motion, as magnitude of velocity remains same, no force no force acts in the direction of velocity vector. No force acts in the direction of velocity vector. That is tangential force. Tangential force is zero. And since only direction of velocity changes, and since only direction of velocity changes, a force must act, a force must act perpendicular to the velocity vector. A force must act perpendicular to the velocity vector and since this force is pointing toward the center, and since this force is pointing toward the center, it is called centripetal force. It is called centripetal force. And we can say that in uniform circular motion, total force is equal to centripetal force. Total force is equal to centripetal force. Now write down for the next line. In non-uniform circular motion, as magnitude of velocity continuously changes, a force is present in the direction of velocity, that is tangential force is always present. Tangential force is always present. But since in any type of circular motion, direction always changes, a force must also be present, perpendicular to the velocity vector and pointing towards the center, which is nothing but centripetal force. And total force on the object is vector sum of these two components. And total force on the object is vector sum of these two components. कोई बहुत डिफिकल्ट चीज नहीं है, अगर आपको डिफिकल्ट लगे पूरी चीज को फिर से एक बार प्ले करके देखना। क्या मतलब हुआ करता है सेंट्रीपिटल का, क्या हुआ करता है टेंजेंशियल का। एक सिंपल लाइन में लास्ट राइट डाउन दिस स्टेटमेंट, tangential force only changes magnitude of velocity. Tangential force only changes magnitude of velocity. Next line. Centripetal force only changes direction of velocity. Centripetal force only changes direction of velocity. Note down everything.